Hi everyone, welcome to part 2 of this week's session on testing mediation and indirect effects. So I closed off part 1 by running through the classic approach to testing mediation as suggested by Barron and Kenny, but I also noted that it was a somewhat old-fashioned way of doing so and that it's been superseded somewhat by newer, more contemporary and arguably better approaches to testing mediation. So I want to start this half of the session by just running through a couple of the most important critiques of that classic Barron and Kenny approach. So the first one is that in the Barron and Kenny approach, an essential first step is for that path C, the direct effect, from the predictor to the outcome variable to be significant. And the argument being that, well, if that's not significant, if you don't have a basic effect of your predictor on your outcome variable, then there is no effect to be explained by a mediator in the first place. Okay. It's increasingly being argued and recognized that it's not actually essential for an independent variable to significantly predict the dependent variable in and of itself at step 1. And the reason for that is that often the associations or the links between a predictor and an outcome variable may be quite distal, either, for example, in terms of time or in terms of the number of intervening steps or variables between them. So we might not always see a clear direct association between them, and that doesn't in itself, though, preclude testing indirect effects. So an example from some of Gordon Harold and colleagues' research looking at some developmental aspects of childhood distress. And in one particular study, they were interested in whether children observing parental conflict between their parents, would predict their child's adjustment, their distress, 1 year later. So that direct association between parental conflict and the children's distress a year later was almost zero. So almost zero direct association. But indirectly, there was a significant indirect effect via, firstly, the child's perceptions of conflict and then onto perceptions of parental hostility. Okay, and that did predict children's distress a year later. So in other words, the link between parental conflict and distress a year later was indirect, even if it wasn't, even if there was no overt direct association. So we see parents in conflict. Our perceptions of them being in conflict increase. That in turn predicts our perceptions of our parents as being hostile per se, and it's that seems to predict distress. So associations between predictors and outcome variables can be quite complex and distal in terms of time or number of intervening variables, so we shouldn't always expect there to be a direct association. A second important critique of the Barron and Kenny approach to testing mediation relates to the Sobel test, and the argument being that there are more robust alternatives to the Sobel test in the form of bootstrapping and using confidence intervals to make inferences about whether the indirect effect is significant or not. The key critique of the Sobel test is that it's vulnerable to bias resulting from violation of particular assumptions and perhaps to small sample sizes as well. So the alternative is an approach known as bootstrapping. Now, bootstrapping as an approach isn't limited to testing mediation hypotheses. It can be used to test all sorts of associations between variables and types of analyses. But in general, a bootstrapping approach involves basically using the computational power available to us these days to run many different simulated runs of your study using so-called bootstrapped samples drawn from the original data. So let's say you've got 100 participants. A bootstrapping approach to testing some sort of relationship in those data would involve creating thousands of new samples, maybe 1,000 or 5,000 new samples, created by drawing randomly and with replacement from those data sets. So the second data set might randomly select 100 values from that original data set, and it can select, because with replacement, what that means is it can select the same value several times if needs be. So each data set will look slightly different from one another and from the original data set, but it is drawing from that original data set. Now, those thousands of new data sets are then used to test the hypothesis or whatever relationship you're looking at however many thousand times. Okay, and what it does then is creates a distribution of effects or estimates from those however many thousand runs of your analysis. Okay, so for example, it allows us to estimate how variable a sample mean or how variable an effect is. And the key for our inference here about whether an effect is different from zero or not is it allows us to construct bootstrapped confidence intervals for a particular effect, in this case for our indirect effect. Okay, so what does that mean? Well, let's think about what a confidence interval is in the first instance. A confidence interval is, in simplest terms, it indicates the potential range of an estimate. So in our case, we're thinking about a mediation effect. What's the potential range of this mediation effect? But we can actually construct confidence intervals for nearly any statistical estimate that we have. The mean for a sample, the difference between means for a sample, or whatever. It's possible to construct a confidence interval. Now, the range of that interval is determined by our preferred confidence level. Now, the default range or the default confidence level for a confidence interval is 95%. Now, that's somewhat similar in logic to the 0.05 cutoff for p-values. Okay, so 1 minus 0.05 is 95, of course. Okay, so a confidence interval has an upper and a lower limit, and these have specific values estimated from the data. Now, a 95% confidence interval, and this is quite a technical definition here. A 95% confidence interval for any estimate means that in the long run, okay, if you ran the study hundreds of times or thousands of times, okay, 95% of the confidence intervals that you get from those would contain the true population estimate, the true population effect that you're after, that value that is the true population estimate. Okay, so 95% in the long run, 95% of tests using your method would produce confidence intervals that contained the true population estimate. Now, this is the key bit for making inferences for mediation for indirect effects. If our 95% confidence interval, now the assumption here is that we're always hoping that the confidence interval that we've got from our study is not one of the 5% that doesn't contain the true estimate. Okay, but what it means is, if we assume that's the case, what it means is if we've got our 95% confidence interval with our upper and lower limits, if the value of 0 falls outside that interval, and we'll see what that means a little bit more concretely in a second, if the value of 0 falls outside that interval, so lower than the lower limit or higher than the upper limit, whatever it might be, then it means that 95% of tests would show that the true effect is different from 0. In other words, it's significant. Okay, what it means is, assuming that your confidence interval is one of the 95% that contains the true population effect, and 0 is not in that interval, then it means that the true population effect is different from 0. Okay, so hence we reject the null hypothesis of 0 effect. Okay, so let's look at that a little bit more schematically to help you get your heads around it. So this is a continuum where we have different sizes of an indirect or mediated effect. And this is a distribution, let's say from our bootstrapping analysis. Let's say we've run 5,000 bootstrap samples, and this is the distribution of indirect effects that we get from those 5,000 bootstraps. Okay. Now, the 95% confidence interval might have a lower limit here and an upper limit here. Okay. And what we're saying here in the 95% confidence interval is that in 95% of the times that we would run this study, the true population effect would fall in this limit, within these limits. Okay. Now for a bootstrap mediation effect, let's say this is the distribution of effects here. We've got indirect effects ranging from minus numbers, from 0 through to positive numbers. And we have our distribution of indirect effects from our bootstrap samples. Let's say our 5,000 bootstrap samples. And we have the lower limit and the upper limit of our confidence intervals. Now here, in this confidence interval, it contains 0. Okay, 0 falls within this confidence interval, these confidence intervals in this distribution. Therefore, we would interpret the effect as not being significantly different from 0, in other words, not significant. Okay. If, however, our distribution of bootstrap sampled indirect effects looked something like this, 0 is not contained in that distribution or within the upper and lower limits. In other words, I mean, if we're assuming that this is one of the 95% of intervals that contains the true effect, then the true effect is not 0. Okay? In other words, we would interpret it as significant. Okay? So just concretely here, let's say we got the following upper and lower confidence interval limits for our mediated effect, our indirect effect. So let's just work through whether we would interpret these as significant or not. Okay, so in this first one here, we've got a lower limit of 0.025 and an upper limit of 0.349. Would that be significant? Yes, because the value of 0 falls outside the interval. It's lower than the lower limit of that interval. Now what about this one here? We've got a lower limit of minus 0.46 and an upper limit of 0.16. And the answer there is fairly clearly no, because the value of 0 falls within those limits, somewhere in between minus 0.46 and 0.16. What about this one here, where we have minus 0.53 and the upper limit is minus 0.03? In this case, yes, we would regard it as significant because the value of 0, again, falls outside the interval. Now, because this effect appears to be negative, the value of 0 actually falls outside the upper limit. Okay. Nevertheless, it's significant. It's a significant negative indirect effect. And finally, this one here. So we've got a minus 0.01 and an upper limit of 0.45. And here the answer is no. We wouldn't regard this as significant because a value of 0 falls within that interval. Okay, so that's the basis for making inferences about indirect effects. Okay, now in terms of actually running the analyses themselves, what we'll be doing is using the jAMM module in Jamovi, so the general linear model for mediation in Jamovi. So this is another one that you have to install yourselves. I'll assume you'll be able to find that and install it yourself. This is the interface. So yeah, make sure you get that installed. And then you'll be able to play along with what I'm about to show you. Okay, so I'll just run through an analysis. I just pop to Jamovi, back to our data file. So these are the same data. And now what I'm going to do is basically test the same indirect effect, but using the jAMM module, using bootstrapped confidence intervals. So it can be found probably under medmod. Okay, so jAMM, General Linear Modeling Mediation Model. So click on that. Okay. Now, in some ways, the setup is pretty much the same as for the Barron and Kenny approach. So we have behavior as our dependent variable. It looks a lot like just running a regression analysis. So we've got behavior as our dependent variable. We will have attitude as our covariate, which is just a name for a continuous predictor, and intention is our mediator. Now, as you can see, Jamovi very helpfully draws out the classics of simple mediation triangle for us, so we can see from what we've entered here what the model looks like, whether we can just check whether our specification is what we intended it to be. So we've got attitude predicting intention, which in turn predicts behavior. So that looks just about right. Okay, So we've nearly got everything we need here. I'll run through the implications of this output in a second. But the final thing we need to do is ask for the bootstrapped estimate. Okay, so we have standard confidence intervals, so non-bootstrapped, if you like, as a default. So what we actually want to do, first of all, is ask for, let's say, 5,000 bootstrap samples, and we want bootstrapped BC. So BC stands for bias corrected. Okay, so they're generally the most robust. So if I click on that, what it will do is rerun the analysis using the bootstrapped process. All right. Now, the one thing you'll notice here is that, again, because it's effectively generating 5,000 new samples and testing the mediation model on those 5,000 new samples, it is taking a little while to work through it, and it tells you as much here. So the confidence intervals will be computed using bias corrected bootstrapping, and this may take a while. Okay, so I took care and actually prepared an analysis earlier. Okay, so this is one that has already run. Okay, so these are bias corrected bootstrap analyses. This is the same model: attitude predicting intention, predicting behavior. And here we have the output. Okay, so we'll just jump back to the PowerPoint slides. So this is that table of estimates. So let's run through what it's telling us, some of the key elements. So this under here component, this first path here from attitude with the arrow to intention, is our path A. That's our path from the independent variable to the mediator, okay, attitude predicting intention, which is highly significant. And then we also have our path B from intention, the mediator, to our dependent variable behavior, which is also highly significant. Okay, so you can see the bits of information here that correspond to that classic triangular schematic, okay, that path diagram. Then we have this direct effect, the path C. So this is the path from the independent variable attitude to the dependent variable behavior while controlling for the mediator, okay, and that is non-significant, okay. And I guess many of the elements of this can be read straightforwardly like the output from a regression analysis. We've got our unstandardized coefficient, the standard error, the beta, the standardized coefficient, the z, which would be the equivalent to a t-statistic, and the p-value. And then the final key bit of information here is along that top row. This is our estimate of the indirect effect from attitude to intention to behavior. All right, this is the coefficient, 0.66, and these are the upper and lower limits for the confidence interval. Okay, so we have a lower limit of 0.39 and an upper limit of 0.99. A value of 0 falls outside these limits, well outside these limits, so we would regard the effect as significant. And actually, Jamovi gives you a sort of a pseudo-Subel test output here, so we also get a z statistic and an estimated p-value as well. But generally, draw the inference from the confidence interval rather than the p-value. Okay. And again, we can help to communicate the results of this analysis by filling in the paths on our diagram with the coefficients that we got from the analysis. So here's the coefficient and the significance from attitudes to intentions, from intentions to behavior, and that non-significant direct path from attitudes to behavior. Okay. Again, summarizing that, we would suggest that, well, the findings are consistent with the hypothesis. Remember, note that it doesn't prove or show mediation, but it is consistent with that specification that intentions mediate the effect of attitudes on behavior. Okay. In terms of writing it up, we've got our coefficient for the indirect effect, an estimate of the standard error, and the upper and lower limits of the 95% confidence interval. Okay, so that's simple mediation done using the bootstrapping approach. Okay. Now, it is actually possible to make our mediation models, our tests of indirect effects, more complex than that. Thinking first of all about the mediator or mediators in the model. It's possible, very possible, to test the role of two or more mediators simultaneously. So let's take that, again, the theory of planned behavior example of attitudes predicting behavior via intentions. Let's say another theorist comes along and suggests, well, maybe attitudes don't just predict behavior via intentions, maybe they also do something else. Maybe attitudes to healthy eating increase our awareness of opportunities to eat healthily. And that has a distinct predictive effect or predictive association with behavior. Okay, so what we have here are two possible indirect effects from attitudes to behavior, one via intentions and one via awareness of opportunities to eat healthily. Okay, so what this is doing, or testing this, will test the indirect path or the indirect effect from a predictor via each mediator while adjusting for the role of the other mediator. So it'll give you a test of the indirect effect via intentions while adjusting for the effect of opportunities, and the indirect effect via opportunities while adjusting for the effect of intentions. Okay. So let's see that in action. Let's just go back to our model. Okay. So this is our mediation model, the first one that we ran, the simple mediation. And we see now that that has completed the analysis, so it only really took a couple of minutes. Now what we're doing is suggesting that there's not going to be not just one mediator. It's not just going to be intentions that we want to test the indirect effect via. We also want to test the indirect effect of attitude via opportunities. So we're going to now move opportunities across to the mediators box as well. Now what that will do is update the model diagram and rerun the analyses with opportunities as a second mediator. Again, I've done that already because it will take a while to work through all the bootstraps. So this is the model. So we can see now we have attitude with its indirect effect via intention, which we already tested, and now also via awareness of opportunities to eat healthily. Okay, that's the model specification that we just did. All right, so this is the output table that we get, and so I'm just going to run through what we would read from this. So now we have not just one but two indirect effects. So we've got the one that we had already tested, so attitude predicting intention, predicting behavior. Okay, that actually looks quite similar to the previous analysis. So the coefficient is 0.6, lower and upper confidence intervals that do not contain 0, and highly significant by the p-value estimate. In contrast, the indirect effect of attitude via opportunities to behavior, that coefficient is a lot smaller, and it is not significant. Okay, because the lower and the upper limit of the confidence intervals of the confidence interval does contain 0. Okay, minus 0.1 to plus 0.28. Okay, contains 0. So it's non-significant. So it looks like we have an indirect association via intention, but not via opportunities. Okay, and each of the paths in that model, again, you can find broken down in this little component section of the table. So this is the path from attitude to intention, from attitude to opportunities, those two A paths, and from intention to behavior and opportunities to behavior, the two B paths. Okay, and then the direct path, the remaining direct path from attitude to behavior. Okay, all of which is contained in that table. Okay, so again, we can summarize that by sort of adding in the details to our path diagram. Okay, so sorry, just pop back there. How we'd summarize that is the indirect path from attitudes to behavior via intentions seemed to be significant, but the one via opportunities was not significant. And we can write those two indirect effects up in the following way. So this is the indirect effect via intentions, okay, and the indirect path via opportunities, not significant. Okay. Now it's also possible to make our tests of indirect effects more complex again. So we looked at how it's possible to increase the number of mediators it's also possible to increase the number of predictors in our model. It's also possible to test the role of 2 or more predictors simultaneously. So our theorist is perhaps suggesting, well, in the end, it's not just attitudes to healthy eating that predicts behavior via intentions and or awareness of opportunities. Perhaps another predictor from the theory of planned behavior that we need to take into account is the perceived norm. Okay, so what is our perception of how others eat? Do other people eat healthily? Do other people not eat healthily? And does our perception of the behavior of people around us, the perceived norm, also indirectly predict behavior via intentions and awareness of opportunities? Okay, so now in this model, drawn out here again in this path diagram, it's very helpful. In this model, we now have 4 indirect effects to test. We've got the indirect effects from attitude via intentions and via awareness of opportunities. And we've also got the indirect effects now from perceived norm via intentions and via opportunities. Okay. So now what an analysis like this will be doing is testing the indirect path from each predictor via each mediator, each of those 4 indirect paths, those indirect effects, while adjusting for, controlling for, on the one hand, the other mediator's association with the outcome variable, so a path via intentions, controlling for opportunities, and vice versa, and also on the A path side, adjusting for the other predictor's association with each mediator. So here, the path from attitudes to intentions will be adjusting, just like in a multiple regression analysis, will be adjusting for perceived norm and vice versa. Okay, so in terms of setting that up and running that slightly more complex model in Jamovi, let's go back to our example. Now that has run, okay, this was the one that we just specified, so it just took a couple of minutes again. Okay, now what we're going to do is look at adding not another mediator but another covariate, another predictor. Okay, so the one variable left here is norm, so I'm going to add it in as a second covariate, a second predictor. Okay, and that will again update the model, update all of the analyses using the 5,000 bootstraps. So again, I'm going to just quickly skip back to a pre-prepared one. Now this is the model, again now with norm specified as an additional predictor. Okay, so just checking that that's the specification we want, which it is. We can go down now to the quite sort of rapidly growing table of indirect and total effects. Okay, so now as I said, we have a list of not 1 or 2 but 4 indirect paths. So starting with the paths from attitude first of all. We've got the one from attitude via intention to behavior. Okay, slightly smaller now, but still significant. Okay, so the confidence interval still does not include 0. And this is the path from attitude to opportunities to behavior, which is still non-significant. Okay, so it has a confidence interval that does contain 0. So what about the paths now from norm? Okay, the perceived norm. Well, this is the one via intention to behavior. That's our coefficient, our standard error, and confidence intervals. So this is why we should primarily look at the confidence intervals, I think, rather than the p-value. Okay, so here we have a confidence interval that does not contain 0. Okay, so we might interpret that as significant. Not by much, but it does not contain 0. However, the p-value is maybe suggesting it's just not significant or not quite significant. So in such a case, which can happen, confidence interval inferences from confidence intervals and p-values don't always align. I would simply report both and suggest that this is an inconclusive finding. Okay, so the confidence interval doesn't contain 0, but the p-value is maybe not quite significant. But of the two, I would tend to go for the bootstrapped confidence interval. And finally, we've got the indirect path, our 4th indirect effect from perceived norm via opportunities to behavior. Okay, coefficient and a confidence interval that clearly does contain 0, so definitely not significant. Okay, and again, each of the components, from attitude to the mediators, from norm to the mediators, and from the mediators, intention and opportunities, to behavior, each of those component paths can be found in the table, as can the two direct paths from attitude to behavior and norm to behavior, okay, both of which are non-significant. Okay, so overall, we might summarize that again by maybe populating our path diagram with coefficients and significance values or little asterisks to summarize each of these component paths, and then summarize it in text by saying something like the indirect path from attitudes to behavior was significant via intentions, but not via opportunities. And the indirect paths from norms to behavior via intentions and opportunities were both non-significant, or rather, I guess in this case with the confidence interval for at least one of those paths, we might suggest that the indirect effect or the analysis was inconclusive, where the confidence interval did not quite contain 0, but the p-value was non-significant. Okay, so that's indirect effects and mediation, and hopefully that provides you with a platform for testing whatever model you might be interested in, but also for maybe extending that into even more complex designs, perhaps where you have more than 2 mediators, or perhaps even more than 1 predictor. Okay, so just to close off this session and the lecture series as a whole, I want to say something a little bit about how this component is assessed. So as you'll be aware, it's assessed via an exam. That exam will, at least the default will be that it is 2 hours long. It's online. It's entirely open book, so whatever materials you want to sit in front of you, you can have them in front of you. And it will only cover material from this module. Okay, and what I mean by that is you will only be asked about techniques that I have explicitly demonstrated in this lecture series. So if I have not shown you how to do it in this series of lectures, you will not be asked to do it in the exam. Okay. In terms of what it involves, you will be asked to conduct and interpret analyses using data sets and descriptions that are provided to you. You won't have to do things to those data sets. They will be provided to you in the format that you need to run the analyses. And then you'll be asked to respond to a series of questions about those analyses. It will involve minimal writing or typing. Primarily it will involve entering relevant aspects of the output and responding to interpretation questions about that output. So there'll be no mini essay writing or short answer question format parts to the exam. So minimal writing, minimal typing. Okay. Much more on that when it comes to the revision lecture at the end of term, and we will also post a full mock version of the exam on which you can practice a little bit later in the term, closer to that revision lecture, okay, once you've had a chance to go through the material from this lecture series. So especially once you've done that, you will have a very good idea of what the exam itself will involve. Okay. Otherwise, that's it for now. I hope you've enjoyed the lecture series. Do let us know if you've got any questions. And yeah, I look forward to seeing you in the revision exam. All right, take care in the meantime.